Hi guys, my name is Jogi Emmanuel. In this video, I'll be showing you how to evaluate trigonometric problems. I want us to read what we have here so that we can be able to solve everything in the autonomous sense. Please subscribe the channel. If you haven't done that, please have a pen, have a calculator, and have a notebook to take notes from this series. I want us to read what we have here. We are saying that if cos of beta, where beta is the angle, is equals to p, and the tangent of beta is less than 0, meaning negative, and p is bigger than 0, meaning positive. Without using a calculator, express the following in terms of p. The a part is a sine of 2 beta, and then the b part is sine of beta over 2. The c part is cos of beta minus 270 degrees multiplied by the tangent of beta minus 90 degrees. Now, before we solve that, I want us to understand what was given as the condition. Now, we are saying that cos of beta, where beta is the angle, is given as such. And now we are also giving you the restrictions, which is the tangent of beta must be negative. It's a quadrant where tangent is negative. Now, we are saying that p is bigger than 0, meaning p is positive. So, I'm going to now look largely where cos of beta is positive. So, I only have two quadrants where cos is positive, and in those quadrants, there is the first quadrant and the fourth quadrant. But now, what restricts me from really focusing on one quadrant is this condition right here, where they say that the tangent of a beta is less than 0 and p is bigger than 0 right there. Now, I want us to think about the two quadrants where cos is positive and the tangent is negative in that quadrant. So if you look at it, you will see that that is the fourth quadrant. So this is where you're going to draw your diagram. Remember that if there's no restrictions of this kind of questions, you always draw your your diagram in the first quadrant right there. So now I want us to draw it right now. I'm gonna draw it. Let me draw. I'm just gonna have a diagram which looks like that. Let me do it like this now. So I'm gonna draw it in the fourth quadrant. If we do that, we're going to have that stuff right there, and then the beta now is measured from the positive axis, which is going to be like that. So I'm gonna write a beta there. And then now I want us to be careful again, because we are given that that a cos of beta is equals to p. Now think about it. What is the trig ratio of a cos of beta? It is the adjacent over a hypotenuse. So here I'm going to write this is over 1 so that I can get my ratio properly. So this becomes your adjacent, and then 1 becomes your opposite, your hypotenuse, and you're going to find the opposite using the Pythagoras theorem. So I'm going to write p here, I'm going to write 1 there, and then now I'm going to get the opposite side. We always use the Pythagoras theorem here. I'm going to write it. So this is x squared plus y squared equals to r squared. So you must write that this is pi. This is by Pythagoras theorem. Must write that this is Pythagoras theorem. What is x? X is the adjacent side, which is a p squared plus y squared is equals to, what is r? R, remember, is the hypotenuse, which is going to be 1 squared. So therefore y is going to be equals to 1. When you square 1, you're going to get 1. You transpose a p squared, you're going to get the square there, you're going to get a p squared. Then now you want to solve the value of y. So you will then say, well, y equals to plus or minus the square root of what? Of 1 minus a p squared. Remember, this is the y value in that quadrant. Now I have to be extra careful. I'm going to check my diagram where it is drawn. It is drawn in the fourth quadrant, and in the fourth quadrant we have the x being positive and we've got the y being negative. So I'm now going to say to myself, well, therefore the correct y value in that quadrant is the -1, where I'm going to have a negative of the square root of 1 minus a p squared. So I'm going to highlight it, that answer of mine there. This is the value of y. This is the value of y in that quadrant. We have found it. And now we are going to answer everything if we have all the sides known to us. Now I want us to answer the a part now of the series. Now the a part is the double angle of sine. We have to evaluate it. A sine of a 2 beta. We only have one rule for the double angle of sine, which is 2 multiplied by the sine of beta multiplied by a cos of a beta. Now we're just going to use trig ratio to evaluate the remaining of the stuff. This is going to be 2 times what is sine in terms of trig ratios is the opposite over a hypotenuse. So you found the opposite, which was minus the square root of 1 minus a p squared. So I'm gonna say, well, this is minus the square root of 1 minus p squared divided by the hypotenuse, which is 1, multiplied by cos of beta in terms of trig ratio is the adjacent over a hypotenuse, which in fact it was a p. Cos beta was given as p from the statement itself. So this then simplify itself to minus 2p multiplied by the square root of 1 minus a p squared. So this is the value expressed, of course, of sine of 2 beta in terms of p. Now I'm going to solve the b part of the series. Now with the b part, we have to evaluate a sine of a beta over 2. If you look at it largely, you'll see that this one is not a double angle of any trig ratio, but we have to be extra careful. It means that we can use some trigonometric manipulation or algebraic manipulation right there. It's just a very easy stuff. Pay attention. I'm going to say, because this angle beta over 2 doesn't really look familiar to us, I'm gonna say to myself, oh, it looks tedious, so to say, I'm gonna say let x be equals to beta divided by 2. All right then, so I'm going to say to myself, well, I have a double angle of cosine, which will give me the value of sine itself somehow, somewhere. Let's check that. I'm gonna say, well, this is a cos of 2x, which is gonna give me, in terms of sine, it's gonna be 1 minus 2 sine squared of the angle x itself. Now I want us to go back and substitute what was our x to us and really see something. This is going to be cos of 2 times x. What is x? I'm just going to write it. My x was beta over 2 from my statement, and this is going to be equals to 1 minus 2 sine squared of x. What is x? X is still beta over 2. Now I have to be extra careful because I have to simplify this out and see what I get. So this is going to be cos of 2 beta divided by 2. This equals to 1 minus 2 sine squared of beta divided by 2. And now if I simplify my left hand side, I'm going to get cos of beta, that equals to 1 minus 2 sine of squared of beta over 2. What am I looking for? I'm looking for sine of beta over 2. But I know what is a cos of beta. I'm talking about this one right here. I know what is that. It was given to me as what? As p. So I'll then say to myself, therefore, this was p. So I'm going to say this equals to 1 minus 2 sine squared of beta divided by 2. Now I have to be extra careful again. Check how. I'm gonna say, well, I'm gonna transpose this sign, this term here to the left hand side, and transpose a p to the right hand side of the equation. So I'm gonna say, well, this becomes 2 sine of a squared of beta divided by 2, that is going to be equals to 1 minus a p. If you transpose anything, remember, it changes the sign. So you will say then to yourself, this is basically a sine of all squared of beta divided by 2, that equals 2. You divide everything by 2, so it's going to be 1 minus p over 2. Remember, what are you looking for? You are looking for sine of beta over 2. But before you get confused, remember that if you have a sine of squared of x, that is the same as a sine of x and then all squared. So what you're going to do is here, you're going to say to yourself, well, let me apply that logic as well to here to say, well, this will be sine of beta over 2 and then all squared, which is going to be 1 minus p over 2. What are you going to do now? You are looking for sine of beta. You're going to square both sides. So this will then mean that your sine of a beta over 2 is going to be plus or minus the square root of a p minus 2. I mean 1 minus p, sorry about that. 1 minus p divided by 2. And then if you want to express it in another way, you can say, well, this is the same as a sine of a beta over 2, that is going to be plus or minus the square root itself of 1 minus p divided by the square root of 2. This is still allowed in that view. So I'm not going to solve the c part. Let's check the c part. The c part is cos of beta minus 270 and then multiply by the tangent of beta minus 90 degrees. So I'm gonna copy that now. I'm just gonna copy that. So the c part, I have to evaluate cos of beta minus 270 degrees multiplied by, let's check that, multiply by the tangent of beta minus 90 degrees. So I'm going to say to myself, this is very much easy. How do I do that? Let me check if I copied it correct. Okay, it's correct now. I'm gonna say to myself, well, because this one is not really a standard form, I'm going to apply some algebra again to say, well, that is basically the same as a negative of 270 degrees minus a beta. Is basically the same stuff. I just took the negative out. You see why I'm doing that. Multiply by the tangent of I do the same stuff. I'm gonna take the negative of what of 90 degrees and say minus beta, and then like that. Be careful. You have what we call the fundamental identities that says that if you have a cos of negative of theta, that gives you a positive of cos of theta. We don't have negative angle of cosine. Then now you will see if you have a negative of tangent of theta, that will then gives you negative of a tan of theta. I'm going to use that argument right here. Pay attention largely. This will then mean that that negative is going to be taken care of, because this is the negative of the angle of that, which because it belongs now in a cos, it becomes a positive of cos of the angle itself, which is 270 degrees minus beta, and then multiply by now, because now check, this is the angle, this is the negative of the angle, so it's gonna be negative of the angle itself. That negative won't be thrown away. Now it's going to be negative of the tangent of 90 degrees minus beta. You see why I'm doing this. And then now pay attention largely. I'm going to say to myself now, therefore, what is this one? It seems like it's a co-functions identity. It's 90 degrees minus a beta. That is an angle in the third quadrant. If you look into that largely, 270 degrees minus beta is an angle in the third quadrant. So you're gonna check is cos positive or negative in the third quadrant. You'll find that it's negative. So therefore, this will become negative. It's the co-function itself. So it's gonna be negative of sine of beta in that view. Multiplied by now, you are going to think about it again. Check, it is tangent of 90 minus beta. If you check, this belongs to the first quadrant. It's 90 minus some reference angle beta, which is in the first quadrant. What I will then do is, in the first quadrant, I will say that everything is positive, but there's negative right here. So hence, I'm going to have a negative of the tangent of beta. You know, so this will then, you know, simplify itself to say, well, the negative cancel each other. So I'm going to say, well, this become what is sine of beta. I have to go back to my diagram and really check what was a sine of beta. Sine of beta is the opposite over a hypotenuse. So it's going to be a negative. It's going to be negative of 1 minus p all squared divided by 1. You know, these negatives, they cancel out, so I might as well cancel them, this negative right here, because they multiply each other. Or if you want them, just put them so that you see their transition. So this will then mean that it is a sine of a beta multiplied by the tangent of a beta. So that when I substitute this value, you see that that one is for a sine of a beta. I'm now going to multiply by the value of the tangent of beta. So tangent of beta is basically the adjacent over, it's the opposite over the adjacent right there. So it's going to be a minus that over p. So basically, you're going to have a minus the opposite is this one. It's 1 minus a p all squared divided by a p. In that case, let me check that and verify with you. Sine, it's the opposite over hypotenuse, perfect, which is minus that over 1, and then the tangent is the opposite over the adjacent, which is minus the square root of 1 minus p squared over p, the adjacent. So I'm going to have that again here. The negative just cancel out. Basically, you're going to have something beautiful, I guess. You're going to have a 1 minus a p all squared divided by a p. So this is how you will evaluate that answer. If you want to simplify it further, you might leave it in this fashion. It's going to be 1 over p, and then